Hi everyone, I'm Liz. Imagine you're a pharmacist. Every day you're flooded with Ozempic requests. Some are for diabetes, some are for weight losses. How do you ensure every single one is 100% safe and FDA compliant in seconds? Meet PharmPal. Ozempic is everywhere, but it's not a one-size-fits-all drug. Current AI model can predict eligibility, but they're black boxes. They can tell a patient why they were rejected based on FDA. This lack of transparency creates safety risks and pharmacist burnout. PharmPal isn't just a calculator, it's a multi-agent system that thinks like a clinical team. It distinguishes between diabetes and weight management path, pulls real-time FDA data, and applies on a hard safety log that overrides any AI hallucination while a patient's life is at risk. Here is how we build the dream team. Our machine learning layer uses LightGBM for efficiency and EBM for interpretability. We then use the TELUS high-tier APIs. GPT-OSS generates empathetic explanations, while DeepSeek V32 acts like a senior auditor, verifying every claim against the FDA corpus. We pre-process the patient features, then run two models to get collaborated probabilities and the top K features. Next, a retriever agent pulls relevant FDA snippets from our corpus. The explainer then to generate a full explanation conditioned on both patient profile and FDA snippets. A validator agent evaluates explanation in two dimensions. Factuality, does it reference to FDA content? Tone, is it clear, safe, and professional? Finally, a reinforcement learning controller updates the system weights based on these metrics, so the agent becomes more consistent over time. Think of it as ensemble learning plus a reward function. Reinforcement learning, just the mechanism we use to nudge the weight towards whichever model produces a more grounded explanations. Our system evaluates two separate things, predictions and explanations. Accuracy measures whether the eligibility classifier itself is correct. For explanations, we use factuality and tone. Tone tells us whether the explanation is safe and clinically appropriate. Alpha here is our baseline tone score. It sets a minimum tone floor, so short explanations don't automatically get zero. Beta is how much each positive keywords increase tone. Factuality tells us how grounded the explanations in FDA text. We combine this into one reward function. This reward does not fine-tune any models, it only adjusts ensemble weights, like a bandit problem, making explanations more consistent across iterations. And this is our Streamlit portal, allows both pharmacists and patients to see why behind the what. As you can see, if we slide the ages, our system verdict automatically changes. And what's more, if you have a family history of MTC, it automatically rejects you no matter what. Let's move to the chat with PharmPal. Here, I will ask him, so it can actually locating with the FDA guidelines. Unfortunately, the API is not really working right now, but everything is linked on the back end, and the patient can freely chat with the agent. They get a conversational agent that explains their eligibility using actual FDA quotes, reducing anxiety and improving health literacy. Check our results. While others chase 100% accuracy on clean data, we introduce 15% clinical noise. Our reinforcement learning controller learned to trust the most stable agent, maintaining 87.5 accuracy. Most importantly, we achieve 100% adherence to safety contradictions. We don't just guess, we verify. Also, we achieve 70% high alignment rewards as well. What's more, in the future, we're hoping that we can implement integration with the hospital ERM and expand it to other high-risk drugs. Don't forget, Canada is a multi-immigrant country that we hope that we can introduce multilingual support here as well.